Start the Wireshark program. Once it opens, verify your interface that's connected to the internet is listed. In my example here, this is the wireless interface. Once we've done that, we click on Capture, Options. And as you see here, we have wireless network connection. And it's even got some data on it as you represent with the traffic in the bar graph. Now, once I've selected my interface, I'm going to click Options. What I want to do is make sure this name resolution is turned off, right? We want to make sure there's no check mark in this resolve MAC addresses. Now, that's on by default. So if you haven't done this yet, if you do your packet capture, you will see the vendor name instead of the MAC address itself. We want the MAC address here. Once you've done that, now we click on Start. Now it's capturing packets. And if you see, it'll start showing MAC addresses and not the vendor names, which is what we want. Okay? So now what we want to do is go to a website. So you can open the browser of your choice. I'm going to open actual Firefox. I'm going to go to Udemy. Now that I went to Udemy, I go back to my Wireshark and I go Capture Stop. Now what I want to do is start looking at the skills we've learned so far and locate the DNS query for Udemy. Once we have found that, then we can look at the connection. So where do we have the DNS query at? Well, it's a little bit of a process, but usually the quickest way is to just, and we'll show you another way later, and here it is at packet 106. Now the reason we want to do this is because you see the query, and immediately we find the response, all right? Once you get the query, once you get the response, then right here starts that TCP connection. Now there's some DNS stuff that happens in between here. Unfortunately, that's what happens anytime you go and open a browser, because so many people are connecting and doing different things on your network. But as you see here is it's going, this send packet, it's going to port 443, which means Udemy is using the HTTPS protocol instead of HTTP. So the data is encrypted. So let's see what happens when we right-click this send packet. Now remember, all the data is in what's called a stream. So if I right-click this and go follow TCP stream, there's all the data within the stream. Even though the data is encrypted, we can still see some of the information that's taking place. Like we can see this signature here of global sign, Cloud SSL, Secure Sockets Layer, California, San Francisco. So we got different things we can pick up as we look down in here. And there's a lot of different things to look at. But again, this is encrypted. So we'd rather, here as we start out, look at one that's not encrypted. So what we do is we close this, we click on Capture, start another capture, continue without saving our packets. Again, it's going to start to capture at the same place we had before. And now we're going to go back to our browser, and we're going to go to Ford.com. I know from research Ford's using HTTP and not HTTPS. You can use any of your own websites to experiment with. So once I've connected to the website, now what I want to do is go back to my packet capture and stop it. And then I got to look for the DNS query. So we go through and we got a lot of data. My cable modem here is making lots of noise this morning. Right here, www.ford.com, right there's the query, right there's the response, and there's the send packet for the three-way handshake. Now, since it's not connecting to port 443, we're connecting to port 80, which means it's in HTTP, Hypertext Transfer Protocol, not encrypted. So now if we right-click, again, all our data is represented on the network in streams. So now if I right-click it and I go follow TCP stream, now we can see information here. Here's Ford.com, which I typed in because remember, I'm the actual client and the client's represented in red and the server's represented in blue. And you just see a lot of good information in here. As you see here, it's setting up a cookie, and I am in Palos Verdes Peninsula in Los Angeles County. And it's picked that up and set a region code cookie on my machine, which is again why so much data mining takes place on the internet. Now, of course, there's ways to get rid of that, but that's another topic. All right. So we don't have the type of server we're connecting to, and that's a good thing for security. A lot of times, we'll actually pick up the server that we're connecting to. In this case, there's no server leakage. So in this case, the people who set up this web server has done a pretty good job because there's not anything that I can detect as a type of web server, which is information leakage. And we don't want to leak that type of information. With defense, we want to leak as little as possible. Now, one last thing we'll look at here before we close up this section. Right here, I can select different options. If I just want to see the server, I just click on this drop down here. I'll show you again. Highlight the area in blue, which is the server, which is usually represented by an address that's not a private address. My address is the 192.168 address. And then when I do the other one, this is the client. So again, this is all the information that's taking place from the client. And you see here the user agent, those types of things, identifies that in fact I'm using Firefox, and I'm using Firefox version 43. So again, now that you understand how this works, you've done your first live capture. So now you can capture anything on a network and analyze it and detect or determine what is taking place. And that's the power of protocol analysis using Wireshark. Next up, we'll continue with more hands-on protocol analysis with Wireshark. We'll give you even more skills to look at the data.